we can think about a vector as something that has both a direction and a magnitude. We can demonstrate the direction by drawing an arrow, like this. So we have an arrow, and then we can ask ourselves, well, what is the magnitude of this arrow? What is the length of this arrow? And the way we do that is by kind of modeling using a coordinate plane, assuming the vector starts at the origin, and we can kind of label this point some x, y. Now x, y is both the coordinate, but it's also x being the horizontal distance, and y being this vertical distance here. Thus, if we call this vector A, putting a little arrow on top to demonstrate that it is a vector, then we can say the length of A, which we will denote using kind of these double lines, is equal to the square root of x squared plus y squared. And we can see this follows from the Pythagorean theorem. Now, we can also ask ourselves, what is the distance between two different vectors? Suppose we have two vectors. I have A equaling, with its coordinates, A1, A2, and then our vector B equaling, with its coordinates, B1 and B2. And then we can ask ourselves, what is this distance here? What is kind of the length of this dashed line? And so again, if we use kind of our distance formula using the Pythagorean theorem, right, we would say that is the square root of A2 minus B2 squared plus A1 minus B1 squared, right? And this would be the distance formula between 2 points in the coordinate plane. However, what we notice is that this is the same thing as the length of a vector whose first coordinate, or whose horizontal coordinate, is A1 minus B1, and whose vertical coordinate is A2 minus B2, which of course this is equal to the vector A minus the vector B. Therefore, the distance between two vectors in 2 dimensions is the magnitude of the difference. So the distance between A and B is the magnitude of A minus B.